All right, so here's our exam 1 test review. All right, so first we're going to look at these graphs and just decide domain, find the domain range and then decide if it's a function. So the domain here, remember we look at basically our x values, so it looks like we're going to go from 3 and then there's no stopping, we got arrows there. So our domain, we're going to want to bracket 3 to infinity. Always use parentheses with our infinity symbols. 3 is included. Unless there's an open circle like you're going to see on number 5, we assume that all points are included. Range. Okay, so in this case, a lot of times students will say, oh, it goes from 1 to 3. Well, these arrows indicate that it's going to continue going down, okay, and then this arrow indicates it's going to continue going up, actually. So our range actually is going to be all real numbers, so it's going to be from negative infinity to positive infinity. And then as far as the function part, if you recall, to be a function, each x can only have one partner, and so we've got a problem here. So right here, this x value's got 2 partners, and oops, and there's some other examples I could show also. And so it's the vertical line test, if y'all remember that. So this one's going to be a no. So as long as if you take a vertical line, drag it across, and it touches at more than one point, there's an issue. Okay, so on the next one here, this time let's see, our domain from left to right, it's going down quickly, but it is going left and right forever. So there are no restrictions from left to right. So this one's going to be from negative to positive infinity. This time the range is restricted. It only peaks at 4 up here. Okay, there is no restriction down below. It goes down to negative infinity. So you always want to go from smallest to largest. So you do want to list the negative infinity first and then the 4, and we'll bracket that 4 in. So if you switch the order on that, you're going to lose some points. So make sure you put the negative infinity first and then 4. Function, this time we're okay. Yes, we got a function. We passed the vertical line test. There's not any part where an x value is giving you 2 different results. And so you're okay on that one. Okay, I want to scroll up a little bit so we can see this a little better on number 5. So domain, once again from left to right. So let's see, how far left do we go? Let's see. 1, 2, 3, 4, 5, 6, 7. So it looks like we're going to go over to 7, or well, negative 7. Okay, and then to the right, we're going to 1, 2, 3, 4, 5. It looks like we're going to make our way over to 5. Open circle indicates that you don't quite get there. So the domain is going to be bracket negative 7 over to 5. We're going to parentheses that 5 in. So it doesn't quite get there all the way. Okay, range. We're going to go from bottom to top. So it looks like we're going to go from, and let's see, we'll change the color on this. We're going to go from negative 3 up to positive 1. So let's see, the negative 3 is included and the positive 1 is not, so we use a parentheses on that. All right, and then function, yes, there were no issues with that. If you check, if you take a vertical line, you should be in good shape. All right, so moving on. This is pretty basic. This is just going to be function notation here. Oops, sorry, it jumped on me a little bit. All right, so function notation, so we're just plugging these values in for the f and g function. All right, so on this first one, I'm just asked to plug in f of 0. And let's see. So here we go. Plugging in 0, so we're just going to have negative 3 times 0 plus 4. So negative 3 times 0, silly. 0, 0 plus 4, so we get 4. So when you substitute 0 into the f function, it simplifies into a 4. Now let's try plugging in negative 3. So we're going to have negative 3 times negative 3 plus 4. So negative times a negative gives us a positive 9 plus 4. 9 plus 4 is 13. Done. Okay, so now the next one you'll notice we have the g. So g of negative 2. So we're going to substitute it in here. So we got to be a little careful. I probably talked about this before, but basically this right here is just the same thing as negative 1 times x squared. So you got to apply the square, then the negative. So when I write this out, I'm going to go ahead and put a -1 there, times -2 squared. Then I get +4 times -2. Then I have a +1 right there. So when I square this, that turns that to a 4. But now I'll apply the -1 in just a second. Then here I have +4 times -2. So plus -6, or if you want to write it as a -6 now, you can. It's fine. Doesn't make a difference to me. Then we still have that +1 back here. Okay, so when you multiply this together, we're going to get -4. Then this right here, we're going to go ahead and write that as a -6. You could leave it like that if you want. And then +1. And now it's just time to combine all these together. So -4, take away 6, that's -10. And then here, if we add 1 to that, that should take us to a -9. There you go. All right. Oops. You know what? I just noticed, I'm sure you were saying this to yourself, what is he doing? That's a -8. And it is. My bad. Let me fix that real quick. I apologize. So let's see. So that should be a -8 minus 8. Let's see, that'll give us a -12. Right, okay, and then +1, -11. So I apologize for that. Okay. All right. Looks good. All right, so moving on, I got more of these. So right here, f of -x. So what we're going to have here is you're going to have -3 times -x. And then we've got the +4 right there. And so what we want to realize is that negative is an understood -1 right there. So when you multiply this together, this actually turns into a positive 3x. Then you have that +4 right there. And that's what we're looking at. Okay. Let's see, let me write this down before I scroll up. So g of -x, that's going to be interesting. So let's see, you're going to have a negative and then another -x squared, okay? Then +4 times -x, and then we have that +1 right there. All right, now I'm going to scroll up so we can maybe see this a little better. Okay, so whenever you square this -x, it has an understood 1 in front, so when you square it, it actually just turns into a positive x squared, but you have that negative that was right there, so actually it goes right back to what it was. That's what it started out with. If you look at the original one, it was -x squared. It actually is going to stay that way, okay, because you square it, this negative goes away, but this one waits till after the power has been applied, so it's still there, okay. Then right here, you're going to have a 4 times -x, which once again, you kind of have that understood -1 in front right there. So this can become a -4x, and then you have that +1 right there. So that's what we get for this. And then our last one, so now what you're going to do is place this x plus 2 into that original f function up at the top. So it's going to be -3 parentheses. You got to put parentheses around it. X plus 2, and then we do have that +4 right there. So all I did, I'll just scroll up so you can see it. All I did was take this function right here and replace that x with the x plus 2. Okay, that's all I did. And I put it in parentheses because I do need to go ahead and distribute. So we'll distribute here and here. So we're going to get -3x minus 6, and then don't forget that +4. And you can consolidate like terms, so we'll go ahead and do that right here. So we're going to get -3x minus 2, and there you go. That's it. Alrighty then. So that's our first page. Let's go ahead and head to the next one. Okay, so the next one is about finding the domain and range of functions. This time it's when we're given an equation. Okay, so this time we're given an equation. So really what you're looking for is any limitations you can find. And so basically we're looking for if you're going to divide, let's say you've got a numerator divided by whatever denominator, basically the denominator cannot equal 0, right? So we need to look out for fractions. And then also, if we're going to square root something, that value inside there needs to be greater than or equal to 0. So those are the two things that we're going to look out for when we look at these. So looking at the first one, right here, number 70, I don't see any fractions and I don't see any radicals. And so really there are no limitations on what I can substitute in for x. So whatever I plug in, that's fine. It's not going to give me any, undefined or non-real solutions. So this domain here is all real numbers. So from negative to positive infinity. There you go. Okay, 71, this one we do have a fraction. So if you remember, the denominator cannot equal 0. So what you do is you take it and set it equal to 0 and ask yourself, what value would cause that to equal 0? And so in this case, it's going to be 7. So that's going to be the off-limits value. You don't want to plug in 7 into this function because you'll divide by 0, which is undefined. So the way we're going to list our domain is we're going to say, we're going to go from negative infinity. So here we go. From negative infinity all the way up to 7, but not including it. So that parentheses excludes it. It's not included. And then union from 7 to positive infinity. So then we'll continue on from 7 to positive infinity. So this is basically the same answer as number 70, except we're excluding one value. That's the only one that really kind of screws things up on 71. So there you go. Okay, 72. Now we're dealing with the radicals. And so that's where you have to take this and say, okay, this needs to be greater than or equal to 0, because if I square root negative numbers, I get non-real solutions. And that's something we'll talk about at a later date. But for now, we want to avoid those. So to solve this, I'm going to go ahead, let's see, I'll subtract by 8, subtract by 8. See, that cancels out. So negative 2x is greater than or equal to negative 8. Then we'll divide both sides by negative 2. And then we're going to want to recall that if you divide by negative, you got to reverse the inequality. So now it's a less than or equals to. And that should simplify to a 4. So the condition is my values need to be greater than or equal to 4 in order for me to get, let's see, yep. So in order for my solutions to come back how I want them. So the way we're going to write that domain here, so everything less than or equal to 4. So that means all the negative numbers, so negative infinity, then all the way to 4. Now we do get to bracket in the 4, because if you plug in a 4, it'll cause you to square root 0, which is fine. You can take the square root of 0. But you don't want to go over 4. If you go over 4, then what this expression will turn into a negative value, and then you'll start dealing with imaginary values. And so, okay, 2 more to go. And if you look back in the notes, you'll find examples just like the ones we're doing here. Okay, so on 74 here, we've got a couple conditions going on. First things first, denominator, don't want it to equal 0, so I'm going to go ahead and take this and set it equal to 0 so I can figure out, what is that excluded value. And I know we can probably just do it in our head, but anyways, I'll show all my steps. Oops. Board's going a little wacky on me. All right, so 5. So 5 is going to be one value that's excluded. So I'm going to go ahead and make that note. So 5 is excluded. My other condition is looking at this inequality, or the radical up here. This expression needs to stay greater than or equal to 0. So we go ahead and solve that, and we say plus 2, plus 2. So my 2 conditions are, and they have to meet both conditions, not just one, but both. It has to be greater than or equal to 2, but cannot equal 5. Okay, so if we were to, sometimes to illustrate this, making a number line can kind of be a little helpful. So let's see, so if we look at this on the number line, here's where 2 is, here's where 5 is. So look, we know 5 can't be included, but this is saying everything greater than or equal to 2. So that would be 2, and then everything greater than it. But remember, it's got to meet both conditions. So you do have to exclude the 5, and then keep shading on, and there you go. So our interval notation for our domain here is going to be from 2 to 5, parentheses, union from 5 to infinity, parentheses. And there you go. There's our domain for number 74. All right, 75, 75. Okay, so once again, remember, it's got to meet both conditions. Okay, so on this first condition, let's see, so we got x minus 1, that needs to be greater than or equal to 0. This other one says x plus 5 needs to be greater than or equal to 0. So real quick, let's see, add 1, add 1. So one of our conditions is saying it's got to be greater than or equal to 1. The other condition is saying that it needs to be greater than or equal to -5. So we got to pick a condition that will satisfy both of these, okay? And so once again, making a number line might help a little bit, and so I'll make 2 of them here. Okay, so let's see, we'll go ahead and put the 1 right here, and we'll put the -5 right here. So one of them saying, you know, 1 to infinity is great. The other one saying, you know what, -5 to infinity is great. The problem is, remember, it's got to work for both of them, okay? So we're going to end up taking the top one. So we're going to go with from +1 to infinity. Because if I go with -5 to infinity, I'm going to be taking values that actually would cause some issues, where I would get square rooting some negative values, and so we don't want that to happen. So okay, so I'm going to go ahead and stop this video here, and I'll pick up and start making a second one to finish off the rest of the review.